response doesn't really start until the utility has had enough trouble puddles that they can triangulate from the locations of the households or businesses that are not receiving service and figure out where the trucks need to go to find the problem. So that's really a really important case where technology that is mature in information technology, data center management, internet management, campus management in businesses of IT resources could be applied to this grid, which is not as complex as some of in terms of the number of nodes and connections as some of the other networks that are actively managed by major applications like HP OpenView, NetCool, things like that do alert management, alert correlation, and root cause analysis in an automated fashion. So with today's technologies, we could be fixing that problem. It's a very interesting thing to say that this spring I went to a smart grid roadshow, and the people from utilities that I was talking to were saying, were describing the alert management problems that they would foresee in the smart grid and saying, this is a really hard problem. We don't know how it's going to be solved. And at the time I thought, wait a minute, this problem is already solved. What am I missing that these people aren't talking about it? There must be some new aspect to the solution that I don't know about. Well, this fall at Grid Week, the picture had changed completely, and everybody was talking about Tivoli and NetCool and HP OpenView and other kinds of network management, data communications network management solutions, and realizing that they had a mature technology that could be leveraged to solve their problem. And now, when we talk to energy service providers, people who are developing or who have long provided applications for the utility and distribution system back office, they're talking about network management or OSS. And so the word is out that that really important technology can just be applied whole to the energy management problem. Real-time operations is kind of another thing. That it's a set of technology and know-how that's extremely mature. I've been doing it, I don't even want to admit how long I've been doing real-time process control designs at various points in my career. But when we go to the utility back office and look at the way the several fairly sophisticated applications that utilities are using for inventory management, geospatial inventory management, customer service management, billing, and things like that, and meter data management, what you have are a bunch of silos where the applications don't really talk to each other very well. And again, there are efforts underway to fix that. But when you talk to a small and mid-sized utility as opposed to the forward-looking ones that are in the news a lot, they're still exporting things out of one application to spreadsheets, having a person transform it and then importing it from the spreadsheet into another application. So imposing a web services model, real-time data collection, and the maturing enterprise service bus technology could really revolutionize the speed at which information for decision making becomes available. Another one that's really, really important is security. Between the mid-'80s when DARPANET started to go significantly public for other than email in colleges to the early 2000s, where we had the essential maturity of internet working and the emergence of Web 2, there were a number of pretty significant security breaches on the internet. And although internet security is not done yet, it's significantly more mature than it was when the interconnection of the wide area networks in the United States and the world really grew together to form the internet. There are security technologies, key management technologies, encryption technologies that did not exist, that had to be developed to solve these problems. But now the security technology, the data security technology industry is mature enough that we can look forward and predict a 20-year, probably future-proof set of technologies by assessing things like the complexity of encryption and applying Moore's law to how fast are people going to be able to apply enough computing power to break these keys and things like that. So you have a mature security set of technologies that can be properly applied. It doesn't have to be redeveloped. Okay. So those are real interesting technologies that people in the data communications and information technology industry can apply to the smart grid, and we don't have to reinvent the wheel, and we don't have to go through this process of recapitulating the invention of those technologies. And my firm really wants to work with the clean energy industry in applying the know-how we have gained in data communications to solve these problems.